what I'll do is, first let me share my screen. Okay, is my screen visible?
Yes.
Okay, right. So I will request everyone to please go to this website called neo4j.com, right? And in the neo4j.com, you will have to so go to neo4j.com, click on the neo4j button, basically neo4j icon, and then you will see there are two options here. One is start free on AuraDB and start free on Sandbox. So today we'll see, so Neo4j can be accessed. So this database can be hosted in many places. It can be hosted in the cloud, which is the AuraDB, right, where the database is hosted on cloud and applications will be using that. Another mode is that is a desktop mode where the database can be downloaded as an application and installed in your own machine, your own laptop or desktop, and you can use the. Give me a second. There's a noise going on. There's some announcement going on. Please hold on. Okay, I think the noise has reduced. So in this, you have so as I was discussing, like there can be multiple modes where Neo4j can be hosted this database. So in the desktop mode, you can install the application on your desktop or laptop, right? And there is this sandbox mode where you will basically they have provided just to experiment with the Neo4j database, how it looks and what are the different functionalities that it can offer. So there is a sandbox mode which runs on from the browser. So basically it is hosted in the Neo4j's own server, and there are some sample databases where we can just play around the Neo4j database and then we can create our own. So this is the sandbox mode, right? So today we'll have a demonstration of the Neo4j database, so on the sandbox, and I'll request all the students to please create or go to this neo4j.com, click on the Neo4j icon, then you will arrive at this page. If you click on start free on sandbox, it will ask for your login, some mechanism to log in. You can create an account in this Neo4j website, or you can use your Google OAuth-based login, right? Google, Twitter, etc., using those accounts. So once you log in, then you will arrive at a page like this. So this is where I'll start my discussion from. So is there anyone who could not, open the neo4j.com website? And I'll give 1 minute to please log into the Neo4j and come to this page. Okay, so once you are in this page, then basically we have to agree to their terms of service. Where do you work? You can write personal or something. And then, so these are some data that they collect, which is okay. I mean, like you can select whatever and then finish it. So this is basically we are trying to create a project where the data is already available with the website, right? We are not providing the data. Today we'll play with this movie database. It's a very pretty standard in Neo4j, where the movie database comes default on I mean, like a playground, right? So so this movie database movies will select, and we'll click on create. Once we have created it, so it will start. Now this screen will appear where it will say open. The database has started there. So at the server side, the database has started. We are opening the client to it from our browser. Right. So if we click on open, it will open this from our browser. It takes a bit of time. So anyone who is not familiar with graph database, I believe Professor Plavon has taken a class on graph database, right? Anyone who is not familiar with database or what a graph database is? Alok Agarwal, are you familiar with what is a graph database? Alok? Alok Agarwal, can you hear me? Shumande?
Yes, sir.
Shumande, what
Yes,
is a
sir.
graph database?
So more or less, the representation of our connectivity between the edges and nodes, we can store it in a form of, I mean, in a particular data store, which, by the way, we'll be learning in Neo4j. As is my understanding correct?
So yes. So but it has to be a little bit more elaborated. So in typical database, when we talk about a database, when we talk about data, it is in association with. So if I just write 5, 6, 7, 8, 10, 15, it doesn't make any sense, right?
Right.
So it's just numbers. So when we
Yeah.
call something as data, that means it has to convey the value of certain attribute, right?
Mhm.
An attribute of what? Attribute of certain entity, right? So there has to be a concept of an entity, the concept of certain attributes associated with an entity,
Right.
and the attributes will have certain value, which could be numeric, string, or other types, right?
Much clearer
So
information about the metadata or of what we are trying to represent, right, sir?
right. So in a typical relational database, whoever is familiar with SQL, they can relate. In a relational database, right, SQL database kind of where we represent the data in terms of like Excel sheet, right? Excel sheet also we capture data. We name the columns, we name the rows, and then there is a Excel sheet. Now, assume that in an Excel file, there are three different tabs, right? Three different sheets. So sheet one has certain rows, certain columns, some data entered there. Sheet two also has certain rows, certain columns, but then sheet two has some dependent row on some on the sheet of one, on some particular column or row of or particular cell of sheet one. Right. So sheet two has some dependency on sheet one. Similarly, sheet three may have dependency on sheet one, sheet two, or both of them, or it can be independent. So this pretty much represents, I mean, with Excel, you can pretty much represent the idea of a relational database, right? Where the data, the rows and columns, the when we try to access, so why database was required in the beginning of Earth, right? I mean, like why at all it was discovered. So the problem before the database came, people used to use file-based systems, right? I mean, our information would have been written in a file. Just assume that there is a log file, right? So in a log file, you have some format, like you can have JSON format, you can have HTML, although these things did not exist at that point of time. But let's say we have certain language with which we could format the data and represent the data in a structured way in a file, and then we could access the file, parse it, get the information out from that, extract the data out from that, and then use that for our purpose, right? So this used to be file-based system. The problem with file-based system was that it is too slow, and the second point was that consistency. If I have multiple files, right? So from one file to another file, if there is a reference, there is no easy way to ensure that this consistency of data between two files is file-based databases, file-based. I mean, like two sets of information in two different files. That could have been easily inconsistent. Like you are changing one file, then just to make sure that the other file is consistent with this data. For example, file one has a property of person's name, right? Name and age. File two has a person's some other property like um, uh, let's say where the person works as an employee in some company name and some company related data. So these are two files. Certainly say, let's say this person one we want to remove from this database. So if you want to remove from this database, so everywhere in this employee set, wherever the person one is referred, that has to be deleted, and that can have a massive change in the second file, right? In the company file. The problem in this kind of thing is that in this kind of file setup is that if we change something in one file, the other many other files may require to be changed at the same time, and processing a file is very time consuming. It's a costly affair, and computationally it is slow, right? Because it has a disk access. Database also needs disk access, but database has a lot more sophisticated mechanism of caching the data and maintaining the consistency. That's how database system came into place, right? And then with relational data, relational database, which I was giving an analogy of like Oracle, SQL database, etc. So there are a lot of relational database. The problem with relational database was that if you want to, I mean, like perform certain operation, you have to, let's say I want to add a new attribute to a particular entity. Let's say this is an entity called person. I want to add a new attribute like what is the favorite color of that person, right? Just to add this attribute, I may have to, I can add the attribute just easily with a command like SQL command into a relational database, right? Like SQL database. But the problem is that if this color has certain notion, which other files may be dependent on, because I'm introducing a new column, which means that this suddenly this new column will have reference be referenced by certain other files, etc. This becomes cumbersome and the operations becomes very costly. So any modification in this relational database is costly, and even certain types of queries are very costly. Not every query. There are use cases where the relational database is the best fit. It's better than graph database. But then graph database came into place because there are certain kind of queries which are not specifically very I mean like efficient to perform the query on in a relational database. Now, Neo4j came into place as one of the most popular uh, graph database. So what we'll do is today we'll go through this graph database where the nodes are entities and the edges are relationships between entities. So in this case, this movie database, let us open that. So, okay, I think I will open this or what? I think I opened this. So once we have our data represented as a graph, then we can run different kind of graph algorithms on top of that. We can do the query directly on the node. So today, like you can imagine connection credentials are not stored here. Okay. Okay. I think now we are connected. So now we are connected to the movies database, right? So now we need to know what is this movies database about, right? Let's say we do not have any information. There is a lot of document here. We'll use some of these. But let's say we are into a database. Somebody has given us a database where some nodes and nodes are represents the entities and some edges represent the relationships, right? For example, in this movie database, we want to see what are the different types of nodes and what are the different types of relationships. So to use any database, there are kind of queries that we can make on the database, right? Database queries. You must have heard this term. Even the non-CS background people. I mean, database is a pretty common word these days, and database queries, etc., also very commonly used. But the database query means that there's a language. There are other languages, for example, C++, Java. These are kind of languages where this is object-oriented language, where you define the objects. Basically, you define the entities and their functions, like how one object interact with another object, etc. So basically, there you specify all the behavior of how this object will work with one another and how their operations will be performed in terms of the functions of those classes, right? So classes and the objects and functions, these are very key things in the design of a database, in the design of an object-oriented programming language like C++, Java. In C, or let's say Python kind of language, where it's typically a procedural language, right? Python is also object-oriented language, so you can design classes, etc. in Python. But let's say in C, you have a procedural language where we step by step write what you want to do, right? There, the idea of relationship and entity, etc., is not very clearly portrayed, and that is one of the shortcoming of C, that it cannot represent very coherently, or it becomes too complex when you write something very complex behavior of different entities and different relationships. The modeling becomes pretty difficult in C because it does not allow the embodiment and encapsulation, right, which object-oriented programming languages do. Now, in the Cipher language or the SQL language, the language that we use on database, let's say SQL is a language which you use on relational database, right? SQL database. Cipher is a language which specifically Neo4j, from Neo4j it has derived and become a standard now. So Cipher is a language that we use to write a program to interact with the graph database. That these type of languages are not procedural language or object-oriented language. These are called kind of declarative language, where we just want to say what you want to get. How to get it is the job of the language itself. So, for example, in SQL, we want to know, like, give me this person's name, where this person has this kind of a relationship with another person. It will give the query. You do not need to do the searching in the tables, etc. That searching is implicitly designed in the query language itself. So when you write the query, you just say what I want to get. You don't mention how I want to get it. Procedural language is about how I want to get it. But in declarative language, you just say what I want to get it. Okay, you don't need to mention the how part. Cipher is also a declarative language. So Cipher is used to query the graph database in Neo4j, right? So we'll use certain Cipher queries. We'll see certain execution of Cipher queries today. The purpose here is to get you familiar with Cipher queries and the kind of potential that we can use in Neo4j. So we'll do it in two parts. Today we'll see some basic Cipher query notations, etc., and how we can access the let's say the browse upon the movie database and perform certain kind of queries. In tomorrow's class, tomorrow's morning class, I think tomorrow is 1 class only. Yeah. So in tomorrow's class, we'll see how we can use this from an application. So tomorrow's part will be like, we'll create a database and we'll, as if the data is our own. You may have your own data or data set or whatever, right? You may be working on some projects in which has a lot of data. You can keep all of that in terms of in a graph database, in a structured way in a graph database, and you can perform queries on top of that, right? So how to do that, and we'll see how we can, let's say, programmatically access Neo4j from let's say Python script, right? We'll see that tomorrow. So let's now dig into this movie database here and how to query the Cipher using Cipher, right? Query the Neo4j database using Cipher. So first we want to know, so match is so these are certain keywords. So whenever you type a keyword, it will become green here. So let's say match n, then return n. Let's see what happens. So see, this is an interface given by like a GUI interface given by Neo4j, where if you perform a query, so this is a query we just wrote and we just run the query, match n, return n, which means that within this first bracket, right, whatever we write, that represents a node. So you can relate that with the circles of the node that Neo4j represents here, right? So match n, so match, even if we don't write n, it can match, but then we cannot return anything because we have not given a name to it. So match this, essentially match first bracket and first bracket close. It essentially means that match a node, right? And n is a name we are giving to that node. So match a node, give it a name n, and then return that node. So return here does nothing, basically returns the node here. And when returns the node here means the caller gets the node back. Now, if you run this query from an application, you will get some kind of uh, response like this. Let's say this is a graphical response which Neo4j browser shows you, but then you can get a tabular response in JSON format. Like uh, I don't know if you are familiar with JSON, but this is kind of a uh, this is the representation of a node, okay, of one node n. So there are many nodes like this, okay. So if we, so let's say we want to see uh, mm, only 5 nodes, let's say. So I think limit 5 will not work here. Limit by 5 will not work here. It will work on this thing. Yeah. So I don't think this will work here. But let's look at the all the responses that it has given in the JSON. So here, say movie has identity 0. So each movie has an ID. Then there are certain labels associated with the movie. So this movie has a basically the associated with a node. So a node can be, so for example, if I ask you what is this node, this is a movie node. So this is that thing, right? The label means it is a movie node. Is the type of the node is movie. Then there are certain properties. For example, the movie has a tagline, "Welcome to the real world," and the movie's name is, the title is The Matrix, and it was released on 1999. So this is a node. It specifically represents this node. If we look at this response from the browser, we'll see. Let's look at a movie. So here I believe the blue ones are persons and the orange ones are movies, right? So um, let's look at the movie Cloud Atlas. If we click on the movie Cloud Atlas, you'll see that released 2000, ID is 10, released is 2012, and tagline is everything is connected, title is Cloud Atlas. So this is the data. So if you now look into this structure, right? So there are different kind of nodes. There are different kind of edges which are connecting these nodes. For example, this node and this node, they are connected by edge acted in. So you can create directional nodes or unidirectional nodes or bidirectional nodes in Neo4j. So for example, this person acted in, so for example, Bonnie Hunt, no, not Bonnie Hunt, I think we can take Snow Falling on Cedars. Scott Hicks directed Snow Falling on Cedars, right? This node. So Scott Hicks directed Snow Falling on Cedars. Now Scott Hicks is a person, right? See, if I click on Scott Hicks, it is showing person, and the ID is 66, born 1953. So there are certain attributes associated with Scott Hicks, this node. So 3 attributes: ID, born, and name. If I go to the movie, the attributes are ID, released, tagline, title, as you were seeing. And then the relationship can have also, the relationship also has type. For example, directed is a type, reviewed is a type. So this person directed this movie, this person acted in this movie, right? So you can have any number of different types of nodes and any number of different types of relationships, right? And within this node, there are these attributes. Within, let's say, acted in also, the edges can also have relationships, can also have attributes. For example, acted in, what is the role that this person plays? Role is Niels Gudmundsson, like that. So Max von Sydow acted in the role of Niels Gudmundsson in the movie Snow Falling on Cedars. So that we can see by just browsing through this, right? Now this is fine. I mean, like if we do this query, it is kind of like it will show us all this huge space where we can browse the graph, etc. But in a real use case, this is not at all useful because we really need to have programmatic access to this. And although we are writing this query here, I mean, we do not need all this information here. Maybe we are looking for a particular movie or particular yeah, user of that, sorry, the actor of that movie, or director who directed that movie, etc., etc. So we'll try certain queries which will basically dig into this in an interactive way, right? And we can write programs using that. I mean, that these queries, whatever I'm writing here, for example, this query, match and return, say one of the simplest query, right? If you want to run this query, it's possible to run from Python, JavaScript, or different kind of languages which has Neo4j drivers for. So if you host the database in a server or in your machine also, laptop or desktop machine, you populate the database, and then population can also be done using the Neo4j drivers, maybe using Python script or other languages like JavaScript, Java, etc. And then you can access, you can in fact write this as strings, I mean like query strings, and connect to the database and get the queries back. But in that case, of course, this graphical view will not come. You will get queries in a formatted way, like in the JSON format and other formats, which we have to, the response you have to parse, and response you have to then basically use in your application, right? So let's now go into some uh, so some more queries. So let's say I want to see what are the different.
Sir, I have one question.
Yes, yes.
Sir, the match and then return, and does it give us the whole graph, all the nodes of the graph, and then all the corresponding edges? Does it do only that work, or is it?
Yes. Basically, see, connecting the edges is not, when I say return n, it means it's just return the node. It is this browser thing is only additionally doing something else for us. So basically return n. So here, see, we have to supposed to get only the nodes. You are not supposed to get the edges. Now, this browser application is this browser, what is graphically showing you. This has an additional kind of behavior that if it finds two nodes which are on the browsing screen now, and which can be connected using a using an edge, it will connect that. So this additional thing is getting additionally done by the browser. It is not part of the query. So if you just do the query, you will get a response in a programmatic language. You will get a list of all the movie names, all the node names. Basically, it can be movies, it can be persons. Right. Only there are two kind of names. That's what we are seeing now. Like if we do label of n, right? Labels, sorry, not labels. So what are the labels of all the nodes? See, there are movie, person. So these are like label of all the different nodes. By the way, in this particular browser, I think there is a configuration somewhere here which says that, yeah, maximum 30 results you show in the screen, because like your database can really have several thousand or even lakhs of nodes, right? It can be in millions also. The thing is that you do not want this browsing space to have a million nodes just because your query returns million nodes, right? So that's why there's a default 30 limit. So even if you do not put any limit here, you just do you just do run a query, it will limit the number of results shown by 30 in the browser part, right? But then in a real program language, when you do that, it will return all the nodes. It will return you in JSON format or other formats. So whatever format you specify, will return all the nodes. Right? It is just a part of this browser, in Neo4j browser, which limits this addition. Again, this can be configured. Now labels in means what are the types of nodes that are available in the database. So I want only uh, the distinct types, right? I do not want the duplicates, like person is appearing multiple times. I want distinct types. And see, I get only two distinct types, movie and person. So from this query, I get to know what are the different types of nodes present in the database, right? Now, let's say I want to see what are the different types of, and let's say one more thing we can do here. Let's also do that. So I can do like this. So it will also say like how many movies are there and how many persons are there in this database. So count star means whatever is the result, count that and put that count, right? So there are 38 movies and 133 persons in this database. Now let us try to see what are the different relationships in this database, right? How will I do that? So see this, as I said, like this, anything in first bracket like this means that it is matching to a node. Then I'll say, so this is called a graphical kind of a language, right? I mean like ASCII kind of language. So ASCII art, right? I mean like you can write use ASCII characters on your keyboard to basically create some kind of graffiti or kind of images, right? So this language also kind of follows that or imitates that thing. So for example, this circle has a edge. So edge is represented by a simple dash, and that edge, let's put a name to that edge, right? So name is R, and that edge is in turn connected with another node, right? Which let us call it M, right? If we do that, then we want, so basically it matches two nodes with a edge connected in between. And we are giving the name of the edge R here, name of the first node N, and name of the second node M. So if we do that, then we return the type of R, because R is our relationship, right? R is the edge. So if we run this query, see there are all these queries, and then if we just, by the way, this up and down arrow gets you to the history, right? History of all commands that has been executed. Up and down arrow in the keyboard. So if we do distinct now, this TNC. See, there are these 6 different kind of relationships in this graph: acted in, produced, directed, wrote, reviewed, follows. Right. So let us now try to match something. So up to this much point, we know that now we know that there are 2 different kinds of nodes in this database, which are movie and person, and there are some 6 different kind of relationships which are acted in, produced, directed, wrote, reviewed, follows. Now we can experiment using this, right? So let's try to match a movie. So we'll do something like this. So whenever you write match, then put the first bracket. This browser gives you certain help these things, right? Help this tooltip. So click on the movie and give it a name. So basically colon movie means match a movie node, match a node which has type movie, which has label movie. So I'll give the name M to that. Okay. So match a node of type movie and give a name M to it, right? Let that movie. Mm, okay. Let us first do another simple query. Match movie this, where M dot. So basically M is the name of the basically the variable of the movie now. So M dot, when you the moment you press dot, it will show you certain these things, certain attributes of that movie M. So let's say M dot title. We want to do, let's say a movie. We want to search the movie Castaway, if it is present. So if this movie is present, and then we return M. So basically what we are doing here, we are trying to match a movie that what the movie's title is Castaway and return that movie M. If it is present, it will return, see the movie Castaway is present. So it has written the single node, right? If we put some other name, let's say Castaway X, just to deny that, and no changes, no records. That means it did not match. Like there was no node which can be matched, right? So now you understand that we can match with the uh, with the attributes of the node. So we can search based on attribute names, right? So this is typical of relational database SQL queries like that. And there we can do something like, let's say we want to search over we want to find a pattern now. Let's say this is a movie network, like social network or movie network. In this movie network, we want to find certain patterns. We want to find where the movie is directed by certain person. Movie. So the moment, again, as I said, like this dash is the edge between movie to another, the age name. So now it is showing all the possible different type of relationships, the ages. So I select directed and I give the name of the age like directed D, and directed by, let's say, person P, who is a person. So what it is matching? It is matching, remove this. It is matching a movie connected to a person where this person has a relationship directed with the movie. Okay. So return M, D, P. So I'm returning these 3 variables, right? So this will return all the different directed relationships, and sometimes this acted will appear because they found that, okay, this node is also present, this node is also present. So Neo4j browser found that I can easily connect this. So it just additionally connected this. But in a real response in this, you will not get this kind of thing. You will get all these MDP pairs, right? This MDP is one pair, this MDP is another, this MDP is another. So all these, not pairs, tuples. So basically this MDP is one tuple of the result. This MDP is another tuple of the result. See, this represents the movie, label is movie. This represents the P person, which is the person who is the director of that movie. And this is the relationship is the directed with all these properties. Now you can understand that you can parse this out using a some kind of a JSON parser, right? And you can easily use this programmatically in your code, right? Now going back to this, is there any question?
Sir, is the graph directed here?
The graph is directed. You can but the query, the Neo4j funda is like you can create a directed graph or unidirectional graph or bidirectional graph. Okay, so like there can be a bidirectional graph also. Here it is unidirectional. All the edges are unidirectional. Now during the query, you need not mention. So first thing is if you create something like this, it will interpret this as bidirectional, and basically it will try to match even any edge that exists. It will match, doesn't matter the direction. If you want to specify a direction, you can do something like this, say something like this movie. This arrow is part of the syntax of Neo4j, but I don't think this will match because movie was not yeah, so this will not match here because the movie is not directed by a person, right? In fact, this direction, it is not in this direction because see, this is an arrow, right? This arrow starts here and this arrow ends here. So this is an edge whose direction is from movie to person, and this is this, but I don't think this will match. Yeah, this will not match. So this was syntax error because I put the arrow in the wrong side. The arrow should be put on the end side, right? Because the direction is on the end side. So these are, the movie is one node, person is another node, the arrow is on the person side, but this will not match because movie did not direct a person directed movie, right? So if I had rather made the query, I don't think this is allowed. I don't think this is allowed in this way. Let me try that. I have not tried this earlier. Yeah, this is allowed also. So see, now this works because person directed movie, right? So if you give an edge direction, this will match. If you give a wrong direction, this will not match. But if you leave the direction from the query, it doesn't matter what direction it is in, it will try to match the query. Right? So is the question answered?
Yes, sir. Yes, sir. Yeah.
Okay. All right. So now let us try to do a couple more queries. For example, so let us try to create something like uh, find movies where the director also acted. Okay, if there are movies like that. So let us try the query. I don't know whether the results will come or not. So can somebody suggest how to do that? I want to find a movie. Okay, you did not see one more thing. I think you need to see one more thing before you can answer this. Yeah, I think you need to see one more thing. Did I show you where m dot title? I think this I showed you already, right? M dot title equal to some name, let's say castaway. Yeah, I showed you this. Return name. Okay. Now, can someone tell? Let's say I want to find all the movies where you see this acted in relationship here, right? Tom Hanks acted in. Let's say I want to find all the movies where Tom Hanks acted. What would be the query? Can someone tell? Try. There's no harm in trying.
So the directed part, after that, this will be D colon acted in, and
Good.
and then there will be P colon person.
right?
Where P dot title equal to Tom Hanks.
I think it's name. The attribute is name equal to Tom Hanks.
Return M.
Return M comma P.
Okay.
And also see the person, right?
Yes.
Something is wrong because Hanks capital H. Yeah. See all the movies of Tom Hanks. That is there, right? So you see now. Now let's make it a little bit more complex, right? You see this thing like Tom Hanks acted also and directed also, right? In this movie, that thing you do, Tom Hanks was also is the director and one of the actor, right? So how do I write that query? If I want to find out all the movies where the same person has acted as well as directed. Anyone?
Sir, is it allowed to put directed in the third bracket after acted in by separating by a comma?
No, this is not a valid syntax. But yeah, your idea, I get it. But unfortunately, this is not a valid syntax. But you can do something like this: Q colon person, another person Q, then another this thing D. Sorry, not D. Let's put it like A colon D was acted in. Let me put this acted in D. A for acted in, D for directed. Now, person Q directed movie and person P acted in that movie. And we can put an additional condition. What is the condition? Where P dot name equal to Q dot name. Return Q D M A P. Let's see if I've written it correctly. Yeah, see, Tom Hanks, that thing you do. Danny DeVito, Hoffer, and this is Unforgiven, Clint Eastwood. So there are 3 movies present in this database, but the same person has acted as well as directed, and we got to know that by running this query. So do you follow the logic? We just matched like we. So whenever you try to find a pattern, the easy thing to think is that I will create the pattern right away. So basically what I'm trying to see here is that I'll straight away write a long line of that pattern. If I can represent that long line of that pattern, then essentially I can name each of these relationships and edges, and then there would be additional relationships on top of that. The pattern is that a person directs a movie, and that movie is acted by a person. Additional relationship is that they two should be same person. Right. Maybe these two can be different persons, and maybe one is the spouse of another. There is another relationship between two persons, whether one is spouse of another. So we want to find. We can find if that information is present. We can find like, is there a movie where one of the spouse has acted and another of the spouse has directed? We can do that. Yeah. Right.
Sir, how would we do, let's say, three such edges like directed, acted in, and produced, let's say?
Directed, acted. Okay. So on the movie, you want to do certain like three such edges, right? So there is one way you can take this intermediate result, and the intermediate result on top of that you can give it a name, and then you can assign that uh, on that intermediate result you can run another part, right? So basically you are finding a subgraph using this, and on that subgraph you can find another query. And I think Neo4j also allows one thing. I have not used that part, so also allows some kind of like a mechanism to kind of create an index like this is a kind of a I'm not sure. I think I read it somewhere. Okay, but I have not used this. So where you can basically create give this sub pattern a name. Say I'm making it up, by the way. I have not checked it. Okay, let me just put it on the table so that we can try it out. So something like W equal to, let's say, this pattern. W equal to this pattern, the pattern which parenthesis starts ends, and then this relationship, and then from W will be another relationship where this M dot will be in the scope of W dot M, something like that.
I see. Okay. Mm-hmm.
So I think this also I saw somewhere, but I have not used it really. But the intermediate result also you can keep. I think we can show that something like that in tomorrow's class. Okay.
Yes.
So where we'll have this. So now you remember we had one. So when I was searching with cast away, let's say, it did not return anything, right? Because it was a, type mismatch. I think I mean, like, it was the case insensitivity, right? So what I'll do a regular expression. Regular expression can be matched here. So for example, instead of directly matching with this, I can match with a regular expression, and I can say something like, for example, put something like this. So this means insensitive case of this, and return M. I think this will work. Yeah. See, now castaway is returned because I just made a regular expression check. So on this castaway, make it case insensitive and match it with as if this is a pattern, not a string, right? And it matched with that title and it returned it. We can have additional things like M dot, let's say, released is greater than 2000. Is there a movie where and I think there's and P dot born is greater than, let's say, 1980. So somebody who is born after 1980 and did a movie so less than 2000. So basically, we are trying to find some kind of teenage actors, right? No, there's no teenage actor here.
Actually, you're searching for teenage director, so maybe you should search for teenage actor.
Teenage director, right? right. Teenage director is a rare. Thank you for pointing out. Let's see if this happens. No, teenage actor is also not present, but is at all. I think some will be present. Yeah, at least some young artists are there. Ninja Assassin, Space Racer, B4. No, these are movies, right? Oh, I have written name. Sorry, I've written aim. Ninja Assassin, Capson. Written M, P. M, D, P. Yeah. So Rain, Emily Hirsch, Natalie Portman, they are young actors who have acted in these movies. So young actors means somebody who was born after 1980, right? And the movie was released after 2000. So see, I mean, like, you can come up with, in a real application, you can come up with different kind of queries, right? And you can, if you just have to frame the high level logic, but you really do not have to write how the graph will be sourced and how it will be found, right? And the benefit of Neo4j is that it has a direct. So whenever there is a by the design of Neo4j, for example, this edge, there is a real pointer underneath from this node to this node. So in many cases, the previous, and there has been other attempts of graph database where prior attempts, right, where this was not an edge, where it was like a kind of created out of a relational table, right? So given a relational table, can you represent a graph? Yes, you can, right? But then that there will be not a direct edge, and then any operation will take a lot of time. Neo4j is the one of the implementation where it directly created a pointer between this underlying Rain node and underlying Ninja Assassin node, so that their access or their search is very fast, right? So that's why it became very popular, immensely popular. And a lot of, I mean, like modern websites, modern, like even I mean, like websites like, in fact, this is popular in, you can go to Neo4j and see their clientele, right? You can understand. Neo4j has a pretty growing clientele. And the good part is there is a free version, desktop version, which we can use. This has certain limits, but I think solutions complexes come from partners. A lot of partners, I think. Yeah, you'll see that there's many, even AWS uses Neo4j, Azure uses Neo4j, and these are, I mean, like Cisco uses. So you can understand, like, this is pretty popular these days. So this you are seeing just some part. If you click on this left side, right, you will get certain ready things. Like if you click on the movie, it will show you all the movies. It will show you person, will show you all the persons. Acted, if you click on acted, it will show you all the acted in relationships, right, in the graph. So there are some ready things just made for our experiments, right? This is the query which is done. Yeah, return p limit 25, which means limit the total number by 25. Now, again, whatever I saw was the just tip of the iceberg. I mean, there's a lot of Neo4j syntax is also pretty vast. The Cypher query is pretty vast. Vast in the sense, like I showed you probably only 2-3% today, which is the most, I mean, like basic thing. But then you can go to the doc, and there are several documentation in Neo4j, and there are several videos available in YouTube also. Take a look at them. If you are, I mean, like apt with the Cypher query language and one of these graph databases like Neo4j, which uses Cypher query language, I mean, you can use it in pretty much, I mean, like all the modern applications that we are doing on, even for this AI and ML researches, right? Where the graph representation is pretty important. So there you can do all this, and you'll see, like I was doing my own research work, right? And there I saw that often it happens that my data set comes as a Excel file. My data set comes as a some kind of a set of images, right, or some set of audio. See, if my data set is like that, I can manage to keep all of that in a Neo4j database. The good part is that if I once keep it in Neo4j database, I manage to keep the data in Neo4j database. I do not have to process the Excel sheet, etc., for different kind of applications. I can have a repository of several such Neo4j data collections, and then I can run lot of queries on top of that for my different kind of research work which uses the same database, right? So even for your own storage of data, you can think of using Neo4j as one of the good mechanism, rather than keeping just simple files. Because if once you are apt with this, if you learn, let's say, if you can just create a Python script, which is not much. Again, I mean, like some bare bone Python scripting has to be done. If you do that, then you can actually import all your Excel data, etc., into graph database, and then any kind of queries will become programmatic access to queries, etc., will become very robust. For example, whoever is familiar with different kind of graph algorithms, right, we'll see some tomorrow. So, for example, I want to find a pattern where, let's say, there is a cycle in the graph, right? Or there is a click in the graph. Let's say I want to find 4 different kinds of nodes, right? Which has a strict relationship of, like, each node has to be connected with another node, another node with some particular type of relationship, etc., etc. So all those can be done pretty, I mean, like without doing much coding. You just need to frame the query. That's it, and then your application can run all that easily. Apart from this, there are, sorry, what is that? Yeah, there is, I think, this one. No, this, there is scripts. Yeah, there is a Cypher help here. I mean, like you can run these help messages, and it has lot of I mean, like you can learn from here, you can learn from the YouTube videos, and you can also learn from the Neo4j official documentation. And then what I wanted to show you was the different kind of applications which are built on top of Neo4j. This interface I'm going to learn from here. Yeah, I think this one, right? On the data side. No, not here. Okay, I'll show you on the desktop version tomorrow. There are applications which you can use on top of Cell. For example, Neo4j can be used with front-end browse websites, right? Using with different kind of JavaScript hooks, etc. And then you can have GraphQL language access on top of Neo4j. So you can use several, I mean, like modern tools which can easily interact with Neo4j and access and update with the database system, right? Internal. So that is one interesting application. I mean, like interesting angle of Neo4j, that it is not just limited to your whatever you're doing with Neo4j, but there are built, I mean, like pre-built applications and very popular applications which uses Neo4j as they're one of the like key component, right? So I think we are tying any particular query up to this date. I know these not a lot of things. You just kind of scratched on the surface of this thing, but I'll request you to go through some of the Neo4j tutorials on YouTube and play on your own. So once you are familiar with this, then understanding the application part will also be much easier. Right. Any question? I'll stop sharing the screen. Any question, anyone?
Sir, do you have any ready DDL DML based queries set of in a list of queries with you that we can quickly get started with?
List of queries on which database?
For Neo4j, let's say I'm just asking for random queries like DDL and DML and creation of a table.
Right. So
Yeah.
these are no. I'll say that go to the Neo4j. There is a, I mean, like introductory how to get started with Neo4j, and
The
they'll
getting
ask you
started
to do
link,
some.
right?
Right. You use that, and they'll guide you to like how to get familiar with the basic queries, like how to create the tables, how to delete the tables, modify the not. There are not tables actually. It's not table. It's create the
It's more
nodes,
NoSQL, right?
relationships, right?
It's more
No, it's not.
NoSQL.
Yes, it is not SQL. It is you
Yeah,
are creating just nodes and edges. So it will give you to commands to create nodes, create
right,
relationships between nodes like that.
right.
So you can create the nodes relationships, and it's pretty ad hoc. Like once you are in the middle of like SQL probably needs you cannot ad hoc create a column or something in there. But here you can ad hoc create a new type of node, give it a new label, and
Right.
this just fits into the whole system immediately.
Yeah, more or less. Basically, I'm relating the same with MongoDB. That's also NoSQL, but has a different sort of queries. You need document.find to get this. Here, I think it is match. So I was looking for maybe a list of queries that can be used, whichever language we're using, as you mentioned before.
Right. The MongoDB is a key value kind of a thing. So it's
Yeah,
basically
yeah.
given a key value, it indexed, keeps everything indexed, and then for a key, it gets the value quickly, right? But
Right,
here,
right.
you think this as of like your and a graph problem, right? Everything is mapped to a graph. Now,
Mhm.
once the data is mapped to a graph, the entities and relationships are mapped to a graph, then our solution space becomes like graph algorithms, right?
Right, right.
In fact, search, etc. All these algorithms are immediately available to you.
Right.
So that's the benefit. You can search for, let's say, you can pose a problem where you find bipartite graph. You can find graph coloring. You can find, let's say, clicks in a graph. So all these graph problems are several. I mean, like 100 graph problems are there. Right? All this fits in right away.
Mhm.
This is the beauty of this database.
Thank you.
All right. Thank you everyone. Then we'll meet tomorrow, and we'll have the next session of this.